Hello, everyone, and welcome to page N1, our first page of notes from semester 2. Let's go ahead and get it started. We're talking about proportions and ratios today. So the first thing we're discussing is a ratio. What is a ratio? Well, a ratio is just a way that we would compare numerous things. So a ratio by definition would be a comparison of two or more. It could be more than two, but a lot of times it'll be two quantities that we compare, two different things. And ratios allow us to create proportions, which is what we're really going to stress using in this next chapter. So a proportion is when we take a ratio and we use it to create an equation that states that two ratios are equal to each other. So if we take two ratios and set them equal, we get what's called a proportion. And this is really important because it's going to help us in exploring all sorts of similar polygons. We're going to start a lot with similar triangles, but we'll see different shapes too as we move through this chapter. But a lot of our chapter is going to be focused on triangles. Anytime we do have similar polygons, though, two things are going to happen. We're going to have angles that are equal measurements. And we're going to have sides that are proportional. So that is always going to happen. That is not even spelled correctly. I didn't spell measures correctly. Equal measures. That's better. So equal measures, but their sides are going to be proportional to each other. Another important way of saying this, a very important phrase that they like to use, I'm just going to write it over here. Angle measures are preserved. That is another fancy way of saying the angle measures stay the same. So really important to know that phrase as well. Angle measures are preserved. So in objective 1, it's asking us to go through here and use the ratios to find the missing sides and angles of a triangle. So we have to take our knowledge of triangles here and use ratios to solve them. So we're going to kind of see how that works. So a ratio of two complementary angles. Well, what does it mean to be complementary? Complementary. Well, complementary means they're two angles that add up to make 90 degrees. So a ratio of two complementary angles. Complementary is two angles that add up to make 90. So the ratio is 3:7. What that means is one angle is 3 times and the other angle is 7 times the size. So what we're going to write is 3x and 7x. Those are two angle measures here. We got two complementary angles, 3x and 7x. And what we're going to do is we're going to take those two angles and add them together. 3x plus 7x has to equal our complementary pair, 90. So let's draw our line here. We know we'll take this and just combine our like terms. 3x plus 7x is 10x. And we could divide both sides by 10 here. That cancels. And I get x equals 9. That is not the question they asked for, though. Make sure you're aware of that. It says find the measure of both angles. That's what they asked. Find the measure of both angles. So we need to go and plug this in now. So 3x is now 3 times 9, which is going to give us 27 degrees. And the other one, 7x, which is now 3 times 9. That's not, why did I put holy cow, y'all. Boop, starting off this semester strong. 7 times 9, that's better. Like that number doesn't make sense. We're going to get 63 degrees. So my two answers here are 27 degrees and 63 degrees. B is very similar. You're going to do the same thing, but instead it's talking about supplementary. So you got to remember what supplementary means. Supplementary is two angles that add up to 180. I'm going to leave that one for you to try yourself there and see what you can come up with for that answer. But we're going to jump down to part C now, so make sure you pause the video if you need some time to do that one. Part C says the same thing, but they gave us a ratio with 3 numbers here, 4 to 7 to 9. That's weird. But it says the ratio of the measures of the angles of a triangle is 4 to 7 to 9. Find the measure of all 3 angles. Well, I know that a triangle always has to add up to 180 degrees. Every triangle of 3 angles always make 180. So I know that this is going to be 4x plus 7x plus 9x equals the total 180 degrees of a triangle. So 4x plus 7x is 11, plus 9 is 20x. So if I add all those x's together, I get 20x equals 180. Divide by 20 on both sides. And I get x equals 9? Yeah, 9. Again, though, not our answer. Not what we want to leave our answers. We got to plug it back in. So 4x becomes 4 times 9, which is 36 degrees. The 7x becomes 7 times 9, which is 63 degrees. And last, we got the 9x, which is 9 times 9 now, and we get 81 degrees. And we could double check that if we add that up, we'd get 180, and we do. So part D, you can see, is a very similar question. The ratio is 11 to 2 to 5. Find all three measures. Again, I will leave that for you to try on your own. All right, objective 2 comes down here, and now we're talking about doing these, the word proportions. There we go. The last one was doing ratios. Now we're doing proportions where we're comparing two ratios to each other. So you'll notice with these, we got these fraction equal to a fraction. I'm going to zoom in on this one. Let's start with this one right here. So when a fraction is equal to fraction, what we're going to do to solve them is we need to cross multiply. Cross multiply. That is how we solve. When you have a fraction equal to a fraction or a proportion equal to, where a ratio is equal to another ratio, you have to cross multiply to solve. So I'm going to take these two things and cross multiply. So I'm going to start here. I'm going to do x multiplied by 2 gives us 2x. On the other side, 4 multiplied by 7 is 28. And what we do with those two values is set them equal to each other. So I'm going to set 2x equal to 28 and solve that problem. So I'm going to divide this side by 2. It cancels out here. And now I have x equals 14 as my solution. Well, B kind of takes that and takes it a little bit further. Now we're going to throw some expressions into these fractions, some things that are more than just an x, right? If it's just 4 over x multiplied 2 over 7, it's a lot easier. But when you have this x minus 1 here, it does make things a little bit trickier because we got to use our distribution rules. So same thing, I'm going to set this up. We're going to multiply x minus 1 times 19. So the way I'm going to write that is I'm going to put the number 19 in front and then put the x minus 1 in parentheses next to it. Make sure you're keeping those parentheses on this entire expression. Don't leave just part of it by itself. And then we got equals, and we'll multiply the 6 by the 13. That's going to give us, what, 60, 6, 12, 18, 78. And so before I really go into solving this problem, I need to distribute this 19 into this expression. So 19 times x is 19x. 19 times negative 1 is negative 19. And now I can go ahead and solve this. So I'm going to add 19 to both sides. That will cancel out here. My 19x comes down. And 78 plus 19 is going to give us 97. And now I can go ahead and divide both sides by 19. That is going to cancel here. And I get a decimal. I didn't realize I had decimals, but apparently I do, and that's okay. Pull out my calculator here. That's not one I can do in my head. 97 divided by 19 is 5.1. So x equals 5.1. All right. Give me 2. All right, sorry. Just verifying my work there. So going over here, I'm going to go ahead and leave part C for you to try. Very similar. Just don't forget, you got to put your parentheses here before you do your distribution. So when we come over here to D and E, D is where I'm going to focus. I'm going to leave E for you. You can see that now I have 2 expressions, and that doesn't really change too much. Just make sure you put parentheses around both of them so that when you do your distributing, you don't mess that up. So in this case, I'm going to have x minus 9 multiplied by 10. So put the 10 outside the parentheses. equals. And then 15 is going to multiply up to the 2x minus 9. So I'll put the 15 outside the parentheses. And then we do our distributing for both pieces here. So the 10 gets distributed here. So we're going to distribute on both sides this time. 10x minus 90. Over here I've got 15 times 2 is 30x. 15 times negative 9 is negative, let's see, 15 times 9, pulling out this calculator, negative 135. All right, now I can go ahead and solve this. So I've got x's on both sides. It does create an extra step here. You always get rid of the smaller x first, so I'm going to get rid of the 10x on both sides by subtracting it. Sorry, I didn't mean to do that. 10x, that cancels out here. So my negative 90 comes down. Don't lose that negative. 30 minus 10x is 20x. And my minus 135. Okay. And now I've got this x by itself. So I'm going to move the 135 away from the x. We got to keep x alone. So add 135 to both sides. That cancels. That's going to give me positive 45 equals 20x. And we got one more step here. Divide both sides by 20. And when I do that, I get 2.2, hold that in this color, 2.25 equals, this canceled, x. This is an equal sign. I don't know why it's doing that. Equals, there. 2.25 equals x. So again, I'm going to leave part E for you to try on your own. Just again, make sure you put those parentheses because that's what will mess it up. So go ahead and pause if you need time to do C and E here. I'm going to go down now to do objective 3, which is use the similar polygons to solve for the variable x. Now with these ones, this statement up top is very important. Those letters are extremely important because we know that these letters, T and C, are both in the first spot because they go together. L and H are both in the middle spot because they go together. Y and K are both in the last position because they go together. So we need to be mindful of that T, let me do this in the right colors. T and C go together. L and H go together. And Y and K go together. So what that tells us then is if we look at this 25 is between T and L, which means it needs to go with C and H on the other side. So it links up with the 10. And I'm going to use maybe a different sum. I'm going to change the color as well. But we know that L to Y, this 4x minus 1, I'm going to put a box around it. Well, L to Y has to go with H to K. So it's matched up with this. So all I did is I matched them together. And now I can create a proportion to solve this problem. Whatever you do, you got to be consistent. So you can do this in any way you want as long as you are consistent. So for example, I'm going to start this off. I'm going to look first at these two pieces here, my purple circles, right? I'm going to set up a proportion with those or a ratio with those. I'm going to put 25 over 10. That's okay, but when I go to do my next one, I have to put 4x minus 1 on top because I put 25 on top. So I'm going to set my other proportion up as 4x minus 1 over x plus 5. So again, both of these things went on top. Both went on top. Both of these things went on the bottom. And then purple circles went in the first fraction. Pink boxes went in the second fraction. So you just got to be consistent. You could have done this all backwards. You could have done 10 over 25, but if you do 10 over 25, x plus 5 has to go over 4x minus 1. You could have put 4x minus 1 and x plus 5 first and put 25 over 10 second. As long as you are consistent, it is okay. Just don't mess up your consistency. All right, I'm going to put parentheses around my two expressions, and we're going to do our cross multiplication step here. So my 10 and 25 cross multiply. So 10 cross multiplies with 4x minus 1 in parentheses. My 25 cross multiplies with x plus 5 in parentheses. So let's see what we're going to get here. 10 times 4x is 40x. 10 times negative 1 is negative 10. Over here, 25 times x is 25x. 25 times 5 is 125. In this case, the smallest x is the 25x, so let's subtract that one. And we're going to end up with 15x, bring down that minus 10, and bring down that 125. Add 10 to both sides. The 10s cancel. And I bring down my 15. Let's see if I can get off that spot. That spot for some reason is messing up. 15x and 125 plus 10 is 135. All right, we got one more step here. Divide both sides by 15. And when I do that, I'm gonna bring this over here, we get x equals 135 divided by 15 is 9. So x equals 9 in this case. Let's double check. Did the question say to find what x was? It did. It says solve for the variable x. So I've got that x equals 9. All right, I'm going to actually leave these last two for you to try. Both of them, just match up your letters and do your problem just like you did above, and you are going to be set. If you have any questions, please